Good morning all. Welcome to 3 classes. I am Srikanth. Today we will be discussing on future value calculation in the case of a single cash flow when frequency of compounding is at increased rate per annum. And this topic also covers continuous compounding and doubling period calculation. And in the earlier video we have already discussed the future value calculation in the case of single cash flow where the compounding is done once in a year. In this particular video, we will be discussing on if compounding is done more than once in a year, how it is going to affect the future value. So, let us proceed. See here we are taking the same example where we have 1000 rupees cash flow in hand and how much it would be worth of after 3 years at a given rate of interest. That is what we have calculated in the previous video. But in this current video, we will be discussing about if the frequency of compounding is at a higher rate per annum, in that case how the future value is going to change. And let us look at how it works out. Generally, we assume that interest is compounded at the end of every year. But in real-time situations, whether it's a bank deposit or a loan taken, interest is compounded more than once in a year at increased rate per annum. If that is the case, let us see what formula we are required to apply to estimate the future value of money in the case of a single cash flow. Future value is equal to present value into 1 plus k by m whole to the power of m into n, where PV is equal to present value or amount invested or received today. FV is equal to future value at a given point of time in the future. That is what we are going to estimate. K is equal to interest rate. M is equal to number of times the interest is compounded per annum, which means that number of times the interest is reinvested into principal amount per annum. It is also called as frequency of compounding per annum. N is equal to number of years. It represents time period. This particular portion which is circled is nothing but future value interest factor. We can observe here that if there is a higher frequency of compounding per annum, the formula for future value interest factor would change a little bit. The component of higher frequency is added in the form of m in the formula. Let us look at a numerical example now. Mr. X invested in a term deposit. A term deposit is nothing but a fixed deposit, rupees 2 lakhs for a period of 3 years. And banks offers an interest rate of 5% on the deposited amount, which is quarterly compounded. Then we are required to estimate how much Mr. X would receive on maturity of this term deposit. So the first step to solve this problem is to identify the formula. The formula we have already discussed, that is F is equal to PV into 1 plus K divided by M whole to the power of M into N. Let us look at the values which are given in the question. PV is equal to 2 lakh rupees, that is the cash flow. K is equal to interest rate. So the interest on deposit is 5%. We can consider it as 0.05 for calculation purpose. M is equal to frequency of compounding. The compounding is done quarterly in this case, which means 4 times a year. So value of M will be 4 in this case. N is equal to number of years. So the time period of deposit is for 3 years. So number of years would be 3. Let us substitute these values into the formula and the calculation as follows. F is equal to 2 lakhs into 1 plus 0.05 divided by 4 frequency of compounding. This entire thing to the power of 4 into 3. So the calculation as follows, and finally this particular future value interest factor in this case will be 1.16075. The answer is 2,32,150. It means that if we are investing 2 lakh rupees today for a period of 3 years at interest rate of 5%, which is quarterly compounded, then in that case we would receive 2,32,150. See, always remember that the power of compounding will be higher and higher if there is a greater frequency of compounding. In this case, M value is 4 because it is quarterly compounded. Generally, banks prefer quarterly compounding. In some cases, it could be half yearly compounding. If it is half yearly compounding, then M value would become 2, which means that the compounding happens 2 times in a year. It is also possible that the compounding is done monthly sometimes. In that case, M value would become 12 because we have 12 months in a year. Sometimes it is also possible that there is a daily compounding, which means that interest is compounded and reinvested into principal amount every day at the end of every day. Then in that case, the M value, frequency of compounding, would become 365. It also happens in certain cases, banks will compound more than once in a day. Let us see the scenario in the following slide. We have a concept called as continuous compounding. If compounding is done more than once in a day, which means that it could be even hourly, it could be even for every second the interest is compounded. It is a scenario where interest is compounded constantly for infinite compounding periods, and this process is called as continuous compounding. In the case of continuous compounding, we use a different formula to estimate future value of money. In the case of a single cash flow, future value is equal to PV into e to the power of r into t. Let us look at the components of the formula, where PV is present value, FV is future value, R is rate of interest, E value is approximated to 2.7182, where T represents the time period. Let us now discuss a numerical example to estimate future value in the case of continuous compounding. We have considered the same example as we have done earlier in this session. Mr. X has invested rupees 2 lakh in a term deposit for a period of 3 years. And bank offers him interest rate of 5% on deposit, but with an option of continuous compounding. In the earlier example, we have quarterly compounding, but in this case, we have continuous compounding. We are required to find out what is the amount received by Mr. X on maturity. As we have discussed earlier, formula for future value is equal to PV into e to the power of r into t. Let us look at the values given in the question. PV is equal to rupees 2 lakhs, R is equal to interest rate 5%, we consider as 0.05 for the problem's sake. E value is approximated to 2.7182. Number of years or time period n t is equal to 3. Let us substitute these values into the formula. Then FV is equal to rupees 2 lakhs into 2.7182 to the power of 0.05 into 3. Calculation as follows. Then future value interest factor in this case is 1.16183. Then the answer future value is rupees 2,32,366. Now we can compare how the future value could change as the frequency of compounding increases. The first scenario is that we have quarterly compounded. The second scenario is we have compounded continuously. In both cases, the present value or the cash flow invested in term deposit is rupees 2 lakhs. The interest rate in both cases is 5%. The duration of investment, otherwise time period of deposit, is 3 years in both cases. But what is happening? The only difference is the scenario in one case is continuous compounding, and the scenario in the second case is quarterly compounding. If we have to look at the power of compounding, how the future value is going to affect because of increased frequency of compounding, let us see. The future value in the case of continuous compounding is 2,32,366, whereas in the case of quarterly compounding is 2,32,150. Due to power of compounding, continuous compounding earns a greater rate of interest or otherwise adds a greater rate of interest for the future value. The future value is 216 rupees more than the future value in the case of quarterly compounding. So with this we can understand that higher the frequency of compounding, despite of all other factors remaining same, higher will be the future value of money. Let us look at the third concept that we are discussing today, that is doubling period. Doubling period is nothing but the time required for amount invested to get doubled at a given rate of interest. Generally, doubling period is what every common man thinks when he has invested. He always thinks that how much time it may take for my investment to get doubled. So the definition of doubling period is, it is a time within which, or the period within which, the amount invested will be doubled at a given rate of interest. Generally, there are many approaches for calculating the doubling period, but in this session we will be looking at very basic and crude approaches. First is Rule 72. Rule 72 is a crude way of calculating an approximate value of doubling period. The formula is 72 divided by k. The second approach is Rule 69. It is also a crude way of calculating the doubling period, accurate than Rule 72. dp is equal to 0.35 plus 69 by k. In both cases, k means annualized interest rate, where k is annualized interest rate. Let us look at a numerical example in this case. Mr. Ram has invested rupees 5 lakhs. We are required to find out how many years it would take to double the invested amount if return on investment or rate of interest is 8%. Now we will be calculating doubling period using both formulas. Rule 72, dp is equal to 72 divided by k. K is annualized rate of interest, which is 8%. So 72 divided by 8. Here we are required to take 8 directly. We need not take 0.08 as we have done in other calculations of time value of money. Then approximate answer is 9 years. It would approximately take 9 years to double the amount invested by Mr. Ram, that is rupees 5 lakhs, if interest rate is 8%. Let us look at the answer as per Rule 69. So doubling period here is equal to 0.35 plus 69 divided by k. Here also we are required to take 8 directly. Then the answer would be 8.975 years approximate, which means that according to Rule 69, if Ram has invested rupees 5 lakhs in any investment opportunity, it could be FD or it could be any other kind of opportunity. If return on investment or rate of interest is 8%, then it would take 8.975 years to double. Hope this session is helpful. We will be discussing present value calculations in the coming session. And thank you very much for watching. Please like and subscribe.